Day 64. Today we're going to be talking about dividing polynomials by binomials. We're going to utilize what I like to call the reverse box method. We're essentially going to take something that we've already used before and do kind of a reverse order of it. So let's go ahead and jump in. So when we divide a trinomial by a binomial, we are trying to find the other factor of the trinomial. To do this, we use fancy term inverse box method, which I call reverse box. All right, so essentially what we're trying to do is we're kind of trying to factor it, but in a different way, okay? So as you can see here, I have x squared minus 5x minus 6 divided by x minus 6, right? So if I was to write this out in a different way, just so it's a little bit more intelligible, it would look like this. You've probably never come across this before, or if you have, they were just asking you to plug in numbers. This is a really difficult process to do whenever you're doing it other methods, but this reverse box makes it easy. Essentially, what you want to do is you start off by drawing your box. So I know because this is a quadratic guy with an x squared, it's going to have 4 squares inside of my box. On the outside, I put the x minus 6, the one that I'm dividing by. Now, I take the very first term and plug it into the very first box. And what I'm trying to do is work backwards to figure out what the other side would be, these guys up here, okay? So I see here that I have x. X times something is equal to x squared. Well, that's x, all right? So now I have x times negative 6 gives me negative 6x, okay? So now I have negative 6x. However, I need to get to negative 5x. How do I get from here to here? I add 1x. And then I ask myself, well, in order to get x, I multiply x times positive 1. And then I say, okay, positive 1 times negative 6 over here. Now I go ahead and I verify by combining like terms. To see if it matches this guy up here. And it does. The other way for us to verify this is just to make sure that this guy times this guy is going to give me this equation. And of course, just like many other things in algebra, we can do that utilizing our calculator. So I'll go ahead and add a graph. I'll say that this is example number 1, the question, right? So this will be x to the power of 2 minus 5x minus 6. We're going to go ahead and graph it. So our other graph should look exactly like this. Let's go ahead and add another graph. So I'm going to say this is my example, answer 1. And I'm going to go ahead and put it in my 2 factors that I found, x minus 6 times x plus 1. And look at that. They lie right on top of each other. So this is most definitely the correct answer. It's as simple as that. All we're doing is just working back and forth in between these, okay? So all we're doing is we're just dividing, but we're kind of doing it in a weird, guessy way, all right? So let's go ahead and take a look at example number 2. Here I have 6x squared minus 13x plus 5, all divided by 2x minus 1. I'm going to go ahead, I'm going to make up my box. I'm going to cut it into 4 because I see this is a quadratic. I'm going to install the first part of my denominator down there, as well as the second part of it. And And of course, I'm going to place the very first term inside of the very first box. We always have to have those three pieces of information in order for us to start guessing. All right, so let's take a look at this. 2x minus 1, 6x squared. So now I ask myself, how do I change a 2 to a 6? Well, I multiply by 3, change an x to an x squared, multiply by x. All right, so I got 1. 3x times negative 1 minus 3x. All right, so up here, I look and I see negative 13x, negative 3x. Okay, so I need to subtract 10 additional x's. Now I go back and I say, all right, how did I turn a 2 into a negative 10? Multiply it by negative 5. X to an x, nothing else to put because that'd just be multiplying by 1. And I've got that. So now I go ahead and multiply by negative 5 by negative 1. That gives me positive 5. Let's go ahead and combine like terms. And I ended up at exactly the numerator, the top portion. In order to verify this, I want to make sure that this graph is exactly the same. So let's head back over to my calculator. I'm going to start a new graph page just because I don't want to get confused with all of that. So I'll say this is example number 2, the question part of it. So 6x to the power of 2 minus 13x. Whoops, hold on. Let me finish typing there. All right, plus 5. Okay, so there's my first graph. All right, pretty cool. Let's go ahead and put in those two factors to make sure that they're exactly correct. And look at that. They lie right on top of each other. Therefore, that is the correct answer. So if you notice, we're doing exactly the same thing. We're just doing it in a slightly different order. Now, technically, another way to do this would be just to factor this like we normally would. One of them should be this, and one of them should be that. We can do that as well. But this reverse box method really helps us whenever we get to higher level math, okay? So I want you guys to make sure you're practicing this skill. So sometimes you might end up with a question that gives you something weird in your box. And that's going to happen with this guy here. So here they want me to take x squared plus 3x plus 1 and divide it all by x plus 4. Okay, that's fine. Let's go ahead and make our box. Okay, so x plus 4x squared. All right, let's start working back. So x times what equals x squared? X times 4, positive 4. How do I get from positive 4x to 3x? I take away 1. So over here would be minus 1 times positive 4, negative 4. All right, let's recombine. Let's go ahead and combine like terms. X squared plus 3x minus 4. Well, wait a minute here. Something is not right. That is not the same thing. Those are totally different. So that means that this is not evenly divisible by x plus 4. Now let's relate this back to our graph. If it was evenly divisible by x plus 4 would be a factor of it. And we should see a 0 value at opposite of this divided by coefficient, negative 4. So let's take a look at that. So I'll start another graph page. All right. So I'll say this is example 3. Here is my original question. So x to the power of 2 plus 3x plus 1. And I look, and I do not see 1, 2, 3, 4. No contact here at this x-intercept that I'm supposed to have if that was evenly divisible. All right. So let us go ahead and continue forth with another one. So this one is also going to be, this is what I would refer to as not factorable, not solvable, lots of different terms that people may use. I'll just say cannot divide evenly. All right, so let's look at the next one. Here they have 2x squared plus 7x plus 4, all divided by x minus 4. I'm going to rewrite that just simply so it's easier to read because we're used to dealing with things in this fashion. And what I want to go ahead and do is I'm going to try and predict whether or not this is factorable by this. So based on this, if I were to take the bottom part, set it equal to 0, I should have an x-intercept at positive 4 on this equation. So let me go ahead and go. I'm going to start a new graph. And I'm going to say, all right, my original equation, 2x to the power of 2 plus 7x plus 4. All right, so I should have one at positive 4. Let me go ahead and move my little equation over here. 1, 2, 3, 4. Does not exist. So that's a quick way to check that this is not going to be factorable. Okay? So let's go back and let's try and do it anyways. Let's prove it numerically. So I'm going to go ahead and get started by drawing in my box. This guy over here. This guy down here. And of course, first term in there. All right. So I'll go ahead and write those in. Okay. So in order to change x into 2x squared, I have to multiply by 2x. 2x times negative 4 minus 8x. How did I get from negative 8x to positive 7x? Add 15x. How did I get from x to 15x? Multiply by 15. And 15 times negative 4, negative 60. All right. So, combine like terms. And this does not match my original equation. Noticing that these C values are totally different. Okay? All right. So I want you guys to go ahead and get started on your example questions and continue forth with your assignment. See you next time.